Hi, everybody. Welcome to topic number 18. In this lecture video, I want to kind of combine the probability questions and the counting problems that we done from the previous two topics together. Okay, so some of these problems here are a little bit more difficult than the one we seen from the previous two topics. So let us dive into it real quick. All right. For example, a bag contains 5 green and 8 red jelly beans. How many ways can 5 jelly bean be withdrawn? Okay, so I'm drawing 5 of them from the bag. Sorry about the typo. So that the number of green ones withdrawn will be less than 2. Okay, so I have a bag that has 5 green, 8 red jelly beans. I want to draw 5 jelly beans. Okay. So the question asking me how many ways the green ones, okay, withdrawn will be less than 2. So think about this, okay? And we're gonna use some of the complement rule that I mentioned in the previous topic too here. So less than 2, that's the key word right here. Less than 2 means 0. So 0 is a possibility, right? I can draw 0 green ones, or I can draw 1 green ones. Okay, gotta be less than 2, so they gotta be 0 or 1. 0 or 1 green ones. So the or tell me to the or is basically implies here we will add the number of ways. So first thing to do is we need to find out how many ways, okay, we will draw 0 green ones. So there are 5 green there are 5 green ones, drawing 0 of them, followed by, right? Because if I'm not drawing any green ones, so that means I'm drawing the red ones. Okay, and I got 8 of them. I got 8 red jelly beans. Okay, I need to draw 5 of them. So that's a total of 8. Okay, drawing all 5 of them using combination, because the order does not matter which one I draw first, second, as long as I draw 5 of them. So this 5 choosing 0 is 5 green ones, followed by drawing 8. Okay, followed by drawing all 5 red ones. Okay, from 8 of them total. Okay, so this will give me how many ways to draw 0 green ones. Or means plus. Okay, now I can also draw 1 green ones from 5 of them. So there's 5 choosing 1 using combination. Okay, followed by, all right, I still have 8 red ones, but this time, since I'm drawing one green, that means I only need to draw 4 for the red. So there will be 8 red total, choosing 4 red ones using combination. So the first part before the plus sign is how many ways to draw a 0 green ones. The one behind the plus sign tells me how many ways I can draw 1 green ones. The rest of it are red. Okay, so that's the computation. So let's put in a calculator. All right, I'm gonna use a parenthesis for the first set. So 5 choosing 0, 5 green choosing none of them, followed by 8 red choosing all 5, because I only need to draw 5, plus 5 choosing 1 using combination, followed by 8 choosing 4. So that will give me 406 ways to draw no more than 2 or less than 2 green ones. Okay, so I know this is a little bit strange. I know it's a little bit difficult to, sometimes a little bit difficult to comprehend, because you got to think, I'm not just drawing I'm not just drawing one, my bag has my bag has both green and red jelly beans. And I need to draw 5 of them. I know I got 13 beans altogether. I do agree with that. But the question want me to draw 5 of them. And the 5 I draw got to be less than 2 green ones. So that's why we break it down into possibility drawing 0 green ones, or I can draw 1 green ones. Okay. So if I choosing 0 using combination, if I choosing 1 using combination makes sense, but you gotta remember, I still have to follow by how many ways I can draw red ones too. While I draw no green, I need to follow by, I also need to follow by how many ways I can draw if I only draw 1 green ones. Let's try another one. John is picking out some movies to rent, and he is interested in horror films and mystery. So I got 2 types. He has narrowed down his selection to 7 horror films and 13 mysteries. Okay, how many different combination of 3 movies can he rent if he want to at least 1 horror movie? So this one is at least 1. Okay, so he want to get, so basically we are selecting 3 movies, basically, right? In the 3 movies, he want at least 1 of them to be horror films. Okay, so let's think about our possibility. At least 1, that means 1 or 2 or 3, because you only want to, combination of 3 movies. Okay, so if you just think about, okay, if you're just selecting horror films, okay, we can have 0. He can select 0 horror films, or he can select 1 horror film or 2 or 3. Okay, these are the possibilities. Selecting a horror, selecting a horror film. At least 1 horror film means what he wants is 1, 2, or 3. So what he don't want is 0 horror films. So we can use the complement rule here to help us figure out what we don't want, subtract it from the total amount, and that will give me what he wanted. So that's the approach we're gonna take. So the previous problem, we directly find 0, or we find selecting 1 green. Okay, that's a more direct way. Sometimes the direct way is not a very good, it actually takes a lot of work. So this problem is actually easier to figure out what we don't want, which is 0 horror film, right? He want at least 1, so that means he doesn't want none of them. So figure out how many ways he will get 0 horror films and subtract from the total. Okay, so if you think about it, there are 20 movies. 7 plus 13 is 20 movies altogether. He's choosing 3 of them total. So it doesn't matter which 3, the order does not matter. So that'll be using a combination. So that's a total. Take the total, subtract what we don't want, which is 0 horror films. Okay, there are 7 horror films. We're gonna choose none of them using combination, because the order which one I pick first does not matter. But when I'm choosing no horror films, then I'm still need to choose 3 movies. That means I need to follow by the mysteries. There are 13 mystery total, right? Choosing all 3 of them. If I don't want any horror films, that means all 3 of them is mysteries. All right, using combination, because the order which mystery I pick does not matter. So that's using combination, C. So this was in the parenthesis is how many ways that will pick 0 horror films. Followed by 13 mystery, choosing all 3 of them. So this is what I don't want, subtract from what I want. Okay, let's put in the calculator and see what we got. So I'm putting in the parenthesis, okay? 20 choosing 3. That's how many ways total. Select, 20 movies, selecting 3 of them. Minus what I don't want, which is 7 choosing 0. Followed by times 13, choosing 3 of them. So there are 854 ways to get at least one horror films. So that include 1 horror film, or 2 horror films, or 3 horror films. Okay, so this is using complement rule to help us. Okay, let's try another similar questions. All right, a certain congressional committee consists of 12 senators and 9 representatives. How many ways can a subcommittee of 6 be formed? So I need to select 6 people. If at least 4 members can be representative. Okay, the 4 can be representative. At least 4 means 4 and more. So that means I can have 4, or I can have 5, or I can have 6. So this problem is probably easier to go directly find out how many ways to select 4 representative, then add on to how many ways to select 5, and add on to how many ways to select 6 representatives. Okay, this is easier to do it this way, because what I don't want is 0, 1, 2, or 3, which is more ways than if I will find 4 or 5 or 6 representative directly. So this question is like the first one I did. Sometimes it's easier to find what we want directly, and sometimes it's easier to find what we don't want first and subtract from the total. Okay, so let's do 4. Okay, let's just think about 4. There are 9 representative. Choosing 4 of them, doesn't matter the order who I choose first, second, third, or fourth, doesn't matter. So that's a combination. Followed by, there are 12 senators. Remember, I'm only choosing 6 people, right? If 4 of them is representative, that means the other 2 gotta come from the senators using combination, because who I pick first does not matter. So this is 4, followed by, excuse me, not followed by. This is or, so 4. Now let's figure out how many ways to select 5 representative. So the word or tell me to add 9 of them, 9 representative, choosing all 5, choosing 5 this time, followed by, there's one more position left, right? I need to select 6 people. So if 5 of them is representative, that means that 1 got to be the senator. So this give me how many ways to select 5 plus, all right, let's figure out how many ways to select 6 representative. There are 9 representative. If I choosing all 6 of them using combination, that means I need to follow by 12 senators choosing none of them. So this one is how many ways to select all 6, to select 6 representatives. This is 5, this is 4, and we add up each way. That give me the answer. Okay. So let's see, I'm gonna put each one in parentheses, okay? 9 choosing 4. Okay, that's how many ways to select representative, followed by this, how many ways to do senators? 12, choosing 2. Okay, so that gave me the total number of ways to selecting 4 representative, plus 9 choosing 5, followed by 12 senators choosing 1, plus, okay, this selecting 6 representative, 9 representative, choosing 6 of them, followed by 12 senators choosing none of them. So that would be 9,912 different ways to have at least 4 representative. Okay. So the next example is a little bit different than the first 3. The next one is only one scenario. Okay, so this problem has 3 scenarios, right? Selecting 4, selecting 5, or selecting 6. There's 3 different scenarios add all together, give me the total number of ways. This one is only one scenario. How many ways can 6 sofas and 6 recliner be chosen? Okay, it tell me exactly what I want. From the shipment of 12 sofa and 11 recliners. So there are 12 sofa, I'm choosing 6 of them, right? It tell me to choose 6 of them using combination. Which one I pick, the order doesn't matter, followed by the recliners. So earlier, this is representative followed by senators in that one way, one scenario. So this is only one scenario. Sofa followed by recliners. 11 recliners, choosing those 6 of them. Okay. So that's it. This is it. This problem is not at least, it's not less than, it's no more than this is the scenarios count. I just want 6 sofa, 6 recliner from the 12 and 11 total. All right, so 12. Choosing 6, followed by 11 recliners, choosing 6 of them. So that gave me quite a big numbers. 426,888. All right. Now the next few example are more geared towards probability type of problems. So what I just showed you, those are counting techniques. Okay, so now let's put counting and probability problems together. So this problem is only one scenario, because this problem says a coin tossed 6 times. What's the probability that the number of tails will be 2? Will be 2 means exactly 2. So I've been saying these wording quite a bit. Okay, at least, less than, no more than, okay, at most, because these are the wordings that we will, will keep on reoccurring throughout this course. Will be 2, another way of saying it is exactly 2. Okay, just like this one. 6 sofa, 6 recliners. So that's exactly 6 sofa, that's exactly 6 recliners. So this is a probability questions, right? So that means I have a denominator. So a coin, so I need 2 tails. So we need to find out the number of ways to get 2 tails. So a coin tossed 6 times. I want 2 tails, okay? So 6 toss, 2 tail. It doesn't really matter, you know what I'm saying? It doesn't matter which tail, which tail first, which tail second. The order of which one is tail, the order of which tails. Because we just want 2 tails. So of the 2 tails, doesn't matter which tail come first, which tail come second. So the order doesn't matter. So I will use combination. So this will give me the number of ways to pick to get 2 tails out of 6 tails. Divided by, this is a probability question, right? Divided by the total number of possible outcome. Well, each toss has 2 outcomes, followed by one another. Each coin toss has 2 outcomes, one followed by the other. So that means that's 2 to the 6th power. So that's my denominator. Okay, so let me figure out the top, then I figure out the bottom. Okay, don't simplify. I'm not simplifying these fractions. Okay, I'm just gonna show you exactly what the answer is. So 6 choosing 2. So this 15 ways to get 2 tails out of 6 tails. Out of 2 to the 6th power, there's 64 possible outcomes when I flip, when I flip a coin 64 times. There you go. So that will be your answer. Okay, I'm not gonna simplify the fraction and leave it like that. All right, similar question, but this time you will say at most 6. So a coin tossed 7 times. What's the probability that the number of heads will be at most 6? So let's think about a scenario. If I flip a coin 7 times, the number of heads, I can have 0 head, I can have 1, 2, 3, 4, 5, 6, or I can have 7 heads, right? When I flip a coin 7 times, what's my possible, what I can get for heads is 0 head, 1 head, 2, 3, 4, 5, 6, or 7 heads. Okay, these are the scenarios I can get for toss a coin 7 times. So these are all heads. How many? So at most 6. At most 6, that means what I want is from 0 head all the way to 6 heads. That's what I want. What I don't want is 7 heads. At most 6 means 6 is the top, right? 7 is what I don't want. So again, I can use complement rule for this one. So the probability of getting at most 6 hits will equal to, okay, this is a probability question. So the highest probability is 100%, which is 1. So that will be 1 minus the probability of getting what I don't want. What I don't want is 7 hits. Okay. So how many ways can I get 7 hits? Well, 7 toss total. I want all 7 are hits. This is a combination because which hit come first doesn't really matter as long as I got 7 hits. So that will be 7 choosing 7 divided by the total possible outcome of flipping a coin 7 times. That will be 2 to the 7 power. Just like 2 to the 6 power up here, that's a total possible outcome flipping a coin 6 times. So flip a coin 7 times, the total possible outcome will be 2 to the 7 power. So this is gonna be 1 minus 7 choosing 7 is only one way. That makes sense because how many way can I get all heads? That will be heads all the way through, right? That will be head. Right? So that's only one way to get all 7 heads out of 2 to the 7 power. If you put in the calculator, will be 128. So 1 minus 1 over 128. The 1 can be viewed as 128 over 128, right? Because the LCD between 1 and 128 is 128 minus 1 over 128. Okay, I hope that makes sense. Whole number 1 is the same thing as 128 out of 128 because the LCD between the two denominator is 128. So 128 minus 1, my final answer will be 127 ways out of 128. Right? So that means there are 127 ways to get at most 6 hits on a 128. Now let's look at another one. All right, a bag contains 4 red, 7 orange, and 4 green jelly beans. What is the probability of reaching to the bag and randomly withdrawing? Okay, this is exactly the red ones, randomly selecting 8 jelly beans. Okay, Harmonic is gonna select 8 such that the number of a red one is 4. I'm gonna take 4 red ones, 1 orange, and 3 green. So that's your 8 right there. So this is only one scenario. I want exactly 4 red ones, 1 orange, and I want exactly 3 green ones. Okay, so this is only one scenario. All right, so this is a probability question. So I gotta have a denominator. So let's do this. Let's selecting the red ones. There are 4 red total in the bag. I'm selecting all 4 of them, followed by there are 7 orange in the bag. I only need to select 1 orange. So that's 7 choose 1, followed by there are 4 green jelly beans. I need to choose exactly 3 of them. So that will be 4 choosing 3 using combination because the order which jelly bean I pick up for doesn't really matter. Divided by. Okay. So how many jelly bean is in the bag total? 4 plus 7 plus 4. So that means there are 15 jelly bean total. And I need to select 8 of them, right? Because I'm drawing 8 jelly beans altogether. So it'd be 15 choosing 8 using combination. So that's my computation. So I'm gonna figure the top first and then write it down and figure the bottom. So 4 choosing 4, followed by 7 choosing 1, followed by 4 green 1 total, choosing only 3 of them. So there are 28 ways, okay, I can select exactly 4 red, 1 green, 1 orange and 3 green. Out of 15 jelly bean total in the bag, drawing out 8 of them. So that will be 28 out of 6,435 ways, 6,435 different ways. Okay, I'm gonna leave my answer like that. All right, last question. This question is a little bit trickier. In a certain shipment of 13 phones, okay, so I got 13 phone total. 4 of them are defective. Okay, so it already told me 4 are defective phones. 11 of the phones are randomly selected without replacement. So once I select them, I don't put them back in the batch. What is the probability that 4 of the 11 phone I picked out are defective? So I am trying to select all 4 defective phones. So this question is asking, what's my probability of selecting 4 of the 11 defective phones? All right, so let's think about this, okay? So let's select the phones, right? So I need to select all 4 defective. Because if this number changes to 3 of the 11 phone are defective, there'll be 4 defective phone choosing 3 of them. But this time you want me to choose all 4 of them. So there are 4 defective phone total. I'm choosing all 4 of them using combination, followed by, okay, if 4 is because I'm taking out 11, I'm drawing out 11 phones total. Okay. 4 of them are defective. So that means there are another, remember the total is 13 phones. If 4 are defective, that means there are another 9 phones are not defective. So selecting defective phones followed by selecting how many ways for non-defective phones. So that will be 9 defective phone, choosing how many using combination. Well, I only need to take out 11 phones total. So if 4 of them I'm going to select are defective out of the total 4 defective phone, that means there's only another 7 phones I can choose from. Does that make sense? Think about it. I got defective phones and non-defective phones, basically. If there are 4 defective, that means there are 9 that's not defective. If I need to select all 4 of these defective phones out of the 11, that means there are another 7 phones I can choose out of the 11 phones I'm taking out of the non-defective. So this gave me how many ways to choose the non-defective. This is give me the way choosing defective phone. Using multiplication because it's one text followed by the other. All right, divided by. I remember there are 13 phones total altogether in the shipment. I'm choosing 11 phone out, so this will give me the total number of ways to selecting 11 phones from 13. Okay. All right, so if you put this upper part in the calculator, that should be 36. If you put the bottom in the calculator separately, put them separately, that should be 78 ways total. Okay, so there are 36 ways to selecting 4 of the 11 defective phones out of 78 total possible ways, possible outcomes. All right, so these homework questions are very similar, okay, to what I just showed you. I just changed the number a little bit, okay? So watch out for these scenarios, okay? Lesson 2, right? 3 movie if you want at least 1 horror films. Okay, that's what you watch out for. How many can be a subcommittee of 5 for at least 4 can be representative. So you gotta think about the scenarios. When you see at least, less than, you gotta think about the scenarios I can get. At least 4 of a 5 means what? That means I want 4 and I want 5. At least 4 means I want 4 and then I want 5 because I'm only selecting 5 for the subcommittee. So this one, you can just find out the number of ways for 4, add on to the total number of ways to selecting 5 representatives. Okay, at least 1. So this one is similar to using complement rules, at least 1. So I can figure out what I don't want, which is 0, and then subtract from the total. All right, this one says will be obtained 1. So that's exactly 1. Okay, Earlier I have will be 2. This one is 1. Okay, this one is at most 2. And this is the same problem, just like defective phones. Okay, what's probability of 3 of the 6 phones are defective? That's what I want to find out. All right, so just real quick, kind of put what we've been talking about in the past several topic together, probability and the counting technique together. Thank you for watching.